Hello everyone. So from today we are going to start a problem session, and my videos will now be based on the questions, the problems based on the theory we have already done in our previous videos. So this is the first problem, and I have tried to include all the basic fundamentals, and let us see what is the problem. The problem for today's video is based on the three compounds I have taken, and amongst the three compounds you can see each of the compound is having C double bond O carbonyl group. So as you can see, all the three have got C double bond O carbonyl group. The question is based on, out of the three, which is the one having highest bond polarity. You should understand C double bond O. As you can see, this C double bond O, this has got a pi bond. Okay, this has got a pi bond. Pi bond is something which can be delocalized easily. It is loosely held by the atoms, so you can shift it easily. And because of the shifting of the pi electrons, we call it resonance also, there will come a bond polarity. So out of the three compounds I have mentioned, we have to predict the one having the highest bond polarity. Now to answer this question, first we have to shift the pi bond. And after shifting the pi bond, a structure will come. That will be one of its resonating structure. If that structure after shifting of pi bond is a stable one, then that shifting will happen with high tendency. And if it is less stable, will happen with lower tendency. And if it shifts with higher tendency, the bond polarity will be more. So first we are going to make that structure after shifting the pi bond, and will then assess its stability. So I will start with A, then we'll go to B, and finally to C. If we see the A structure, the A compound, so I am starting with A. As you can see in A, after the pi bond has shifted on oxygen, so how I have shifted, please have a look. This is the pi bond, and I have shifted it over oxygen. So you should understand, and I have been telling this all my videos, the atom which loses the electron, or the atom from where the electron goes away, a plus charge comes. So from this carbon, the electrons are moving away, so it will have a positive charge, as you can see. And the pi electrons are going towards and sitting over the oxygen, so it will acquire the negative charge. And this is what I am talking about, the structure where the pi bond has shifted on more electronegative element, oxygen, and this results in bond polarity. So student, you should understand, this shifting of pi bond on oxygen results in bond polarity. What is the meaning of polarity? Polarity means development of plus pole and the minus pole. So how you are going to develop it? By shifting the pi bond on more electronegative element, and in our case that is oxygen. So student, after we have made this structure, we have to assess, we have to see whether this structure is stable or unstable. The more it is stable, more it is likely to get formed, and higher will be the bond polarity. So if you see this plus charge, immediately you realize that, oh, there is a resonance. Of course there is a resonance, as you can sing a song. As I have drawn the structure, you can simply see plus, single, double. From left also and from right also you can sing the same song, plus, single, double. So it's a situation of cross conjugation. So in this case, in these cases, I have told you to shift the pi bond towards the positive charge. Student, as you shift this pi bond towards the positive charge, this carbon is going to get deprived of the electron. And as the electron goes away from this carbon, it acquires a positive charge, as you can see in the next structure. And the pi electron goes to form pi electron goes to form the next pi electron. It shifts one position next, as you can see the shifting, and towards the atom where it shifts, towards which it shifts, a minus charge comes. So minus and plus becomes 0. So this carbon gets a 0 formal charge. Now you can see again there is a possibility of resonance. This is a plus charge, plus, single, double. So you can shift this double bond towards the plus charge like this. And as you have shifted, again this particular carbon is going to lose the electron. So you can simply see a plus charge comes over it. The pi will not be there anymore and it will shift one position ahead. And as you can see, it has shifted one position ahead, and towards this carbon it has shifted, a minus will come and plus minus 0. So student, the last structure, as you can see, is something amazing. It has amazed us in the point that a benzene ring is seen. As you can see, a benzene ring has came. This is a symptom, a symbol of a sign of aromaticity. The benzene is an aromatic compound, and the species which reflect the benzene ring character does show aromatic behavior. So from here what we have realized, that shifting of the pi bond of C double bond O, a plus charge came in the ring. After doing some resonance, we have come to a structure which has got a benzene ring. That benzene ring is a symbol of stability, aromaticity. And since it is stable, the shifting of pi bond will occur with higher tendency. So if the pi bond shifts with the higher tendency, you should realize the bond polarity will be higher. So we have seen the case A, and the basis is aromatic ring is coming by shifting the pi bond, and that is the thing which is giving push for the shifting of pi electron for the creation of bond polarity. Now students, coming on to our structure number B and try to assess. First, the same thing we are going to repeat. First, we are going to shift this pi bond over the more electronegative oxygen. And as you can see, the electrons are running away from this carbon. So a plus charge will come here, and it is shifting over the oxygen. A minus charge will come. After looking at this, you suddenly realize, oh, this plus charge is in conjugation, the cross conjugation position. From left also, right also, you can sing the song plus single double, plus single double. Any way you could go. So if I shift this pi bond like this, you understand, it will go away from this carbon. So plus charge will come here. The pi bond will shift one position ahead, as you can see it has, and the plus charge will get a minus, and plus and minus becomes 0 formal charge. All the rules and regulations what we have been following till this date. Now after this, you can realize you could have gone from right direction also. We have done from the left. You could go from the right also. From the right, if you had done, this structure would form. So, I mean, after looking at the resonating structures, how many resonating structures? The 4 structures in front of you. You do not see, although it's cyclic, but you do not see a cyclic conjugation. So there is no question about aromaticity coming to this compound. Let us try to say it. For an example, if you do like this, let me clear this. If you count this plus charge, plus, single, double. From the right, from the left, plus, single, double. So you can simply see this particular carbon is the culprit, is under scanner. Why? Because in the conjugation, this is not coming. So there is no cyclic conjugation. So although there is a possibility of resonance, although the plus charge which is coming in the ring is delocalized by resonance, but that delocalization does not ensure aromatic behavior, which we had got in the previous case. So previous case A has an edge, is more stable than this particular resonance case, because in the previous case you got aromatic character and that is much higher than this non-aromatic behavior. So the bond polarity in A will be greater than B. Okay, now coming on to our next competitor, the compound C. In this compound you can simply see, again you have to follow the first fundamental step. You have to shift this pi bond over the more powerful oxygen, and by doing this you have created a bond polarity, as you can see. After looking at this, you have suddenly realized again the plus charges in conjugation, in fact the cross conjugation, plus single double from right also, plus single double from left also, any way you could go. For an example, I have chosen the left way. So this pi bond will shift towards this, and as usual, as we have been doing, the pi bond will advance one position, the plus will come on this carbon, and this carbon where plus was originally there, a minus will come and plus minus becomes 0. Now after looking at this plus charge, you again realize that, oh, there is one more possibility. Plus single lone pair, which I have already spoken about, is one of the condition of resonance. So what happens in this case? These lone pair just flips over towards the plus charge and make a pi bond, and as you can see, a pi bond has been created, and as it goes away from the oxygen, this oxygen acquires the plus charge. As it goes towards this carbon acquires minus, and plus minus becomes 0. Now as you see this particular structure, the last one, immediately something unusual thing you can see. And what is that? You see an aromatic behavior. How do you see this aromatic behavior? You should realize there is a ring, as you can see, a 6-membered ring. You have 5 carbon and 1 oxygen. Is there a cyclic conjugation? Let us try to see. Okay, let us try to sing the song. Double, single, double, single, double. Oh, this conjugation song has included all the atoms in the cycle. So there is a cyclic conjugation. And let us not forget about the validity of Huckel's rule. If Huckel's rule is also valid, we will declare it as aromatic structure. So you should understand how many pi electrons? 2 from here, 2 from here, and 2 from here. 2 plus 2 plus 2. In all you have 6 pi electron, which is following Huckel's rule, 4n plus 2 for n is equal to 1. So you understand the compound C, after shifting of pi bond of carbonyl, develops an aromatic character, and this is the structure we have been talking about. So if you remember the case A, the case B, and now the case C, what you have realized? You have realized that case A was giving you aromatic character, case B was not giving. Again case C is giving you some aromatic character. Now there will be a tussle, a contradiction between A and C, because B is out of the competition. Now we will compete between A and C. You should understand why we have to do a competition between A and C, because both have got aromatic structures. In that point of view, they are parallel. Now we have to come up with some point of difference that could realize us that one is a stabler structure than other. Then we will say this will have the more bond polarity. Now if you see the structure A and C, can you see a difference? I can see a difference. I have seen a major difference between A and C. Students, I have seen that structure A, this carbon, this particular carbon if you talk about, this is a carbocation and this has got 6 electrons. Carbocation has got 6 electrons. That means its octet is incomplete. Its octet is incomplete. Although this was boasting about its aromatic character, let it boast, but I will have one point to say here. You see, you are not having the carbocation fulfilling its octet. That is your demerit. And if you talk about the structure C, you should understand all the atoms, apart from having aromatic character, all the atoms have got octet completed. If you talk about this oxygen, this is having 3 lone pairs. So if you count 2 to 4 to 6 to 8, all the carbons, because you should not forget each carbon like this, since it's a bond line diagram, has 1 hydrogen as well. So all these 5 carbons are having 8 electrons, and nonetheless this oxygen, although having the plus charge, is octet completed. If you count the number of electrons, 2 from the right, then from left 2 to 4 to 6, and the 1 lone pair, 6 plus 2, 8. It's an oxonium ion which is having the completed octet. So there is an extra advantage with the structure C, that although it had the aromatic character, it also had the octet completion. And finally the winner is C. And winner in what context? The context is clear, what we had started with. We will shift the pi bond. We will get a carbocation there. We will get a plus charge in the ring. We will do some resonance and try to see the stability of the structures. Immediately we found the structure A and the structure C. In the compound A and the compound C had aromatic structures. Then in order to break the tie, we saw that the C had an extra advantage. What? All the atoms had completed octet, but the structure A lagged it at 1 carbon, which is carbocationic carbon, had incomplete octet. That is how we deciphered the C is going to do the bond polarization. The shifting of pi bond in the structure C, in the compound C, will happen with utmost ease, with most tendency, and that is how it will have the highest bond polarity. And in a similar manner, we are going to do more questions based on aromaticity. We will apply different resonating structures, different concepts which we have already dealt with in our previous videos. Till then, take a good care of yourself. We will meet with the next video based on the next problem. Thank you very much.